Moving on to our next presentation, I'm pleased to introduce Sarah Ostadabbas. Sarah is an assistant professor in the Electrical and Computer Engineering Department at Northeastern University, the director of the Augmented Cognition Laboratory, and an associate editor of the IEEE Transactions on Biomedical Circuits and Systems. Professor Ostadabbas and her team at Northeastern University built a visual technology to assist with early diagnosis of developmental disorders. The preliminary work around this topic is based on a collaboration among Ostadabbas's lab and multidisciplinary researchers at Northeastern and the University of Maine.
Hi, everyone. Thanks, Sergey, for the introduction. I'm Sarah Ostadabbas, an assistant professor of electrical and computer engineering at Northeastern University. My research interests are at the intersection of computer vision and machine learning, with particular focus on representation learning algorithm. On the applied side of research, my work has primarily contributed to understanding, detecting, and predicting human behavior by estimating their physical, physiological, and emotional state. As part of one of my human state estimation work, we are developing and try to bring to market the first of its kind artificial intelligence guided cloud-based baby monitoring system called AI Wover to watch over babies. AI Wover track babies' every movement in their playground, playroom, or crib whenever camera is there, categorizes their pose and posture as you see here, and analyze also their motor function reliably to provide parents with a smart way to monitor the baby's activities and development. Any of you with parental experience can imagine the burden associated, especially for caring your baby for the first few years of their life. While being sleep deprived, you want to keep them safe and also make sure they pass each developmental milestone set forth by the pediatrician. However, people buy baby monitoring system to let them directly observe the child and also provide alerts when something happens. For example, if they are crying or they have woken up. However, the visual trigger on these systems are often simple motion within zone trigger and has a lot of false alarm. Whenever baby moves, it's called an alarm, and also fail to catch events of interest such as lethal or otherwise very serious injuries that can be preventable. Here I'll show some of also neurodevelopmental disorder that can be detected even from the crib, such as cerebral palsy or autism spectrum disorder, and also sudden infant death syndrome during sleep. Unfortunately, none of the current baby monitoring system offer this long-term monitoring capability that can track child development and also can prevent or alarm when something out of norm happens, such as crib injuries that you see happen here, unfortunately. Until AI Wover. In my lab, we developed this AI-based system based on purely computer vision and machine learning algorithm that allows for very accurate infant pose estimation, posture tracking, and also action recognition. And since we collect much needed data for the model through this monitoring system, we also can use advanced AI to interpret data and provide summaries and user-friendly alert to the users, such as parents, pediatrician, or even developmental specialists. While we have seen a huge leap in and success in action recognition for adults, when these models apply on babies, infants, as you see, they fail to perform robustly because there is a huge domain gap between adult population and pose distribution as compared to the infants. So in my lab, we address this problem using two essential ingredients that we have in our possession. First, we developed data efficient models based on the advancement that happened in the last few years in data efficient machine learning. Also, we also expanded data set by using synthetic generative models, such as you see that the avatars of infant, to expand the data set to be able to have model with complex backbone. Here you see an infant cruising around. He's actually my son last year cruising around, and right side shows AI Wover, which is much more robust in detecting these subjects posed throughout the daily activity. And also here, a view of the very, very recent app that we have that summarizes babies' daily activities, a specific posture that they are taking, also a specific action that have gone through. This action can be adverse action or the actions of interest that is important for the milestone, and tracking automatically the milestone based on the age. We also, for the parents that they are very busy, the app capture the events of interest, such as the first time that the infant is rolling, and you may have missed that. In short, not only for all of this to keep the parents in peace of mind, my lab tries to bring AI in from the vision base, which is a very unobtrusive base of tracking infants, to not only make sure the infants are kept safe, but also track motor impairment in infancy. And this very early detection allows for targeted intervention, and also have cascading effect in multiple domains of infant development, including the communication, then later on the social, cognitive, and memory. This work couldn't be done without the help of a very awesome group of students and postdocs that I have, and the support that I have received from a government agency as well as different industry partners. Thanks.